I am Latoya Shiraya.
And I am Karima Mundell Thomas. And we are your teachers for today's mathematics lesson.
Let's begin.
Definitely.
All right, so today we're continuing looking at transformations, and we'll be looking at rotation in particular today. But Karima, before we start, I have a story to tell you, right?
As usual, but let's
hear it. So I was
it.
passing by my neighbor's house, and they're getting some tiling done in the driveway. So I was just, kind of looking, and not fast, I just a little bit inquisitive.
Yes, same
so
thing.
I was looking, and the tiler man was out there tiling and thing. And then I realized that he had the tiles placed like this that you're seeing on screen.
What?
And I said, sir, excuse me, please, in the nice, calmest of tones, of course. And I was like, I don't think you put them properly. They're two halves, but I think it's turned the other way. And I think there is a nice flower pattern that should be coming out.
Right in the middle there.
With the blue on the inside.
Yeah.
And so I was saying to him, just turn it like this. And turn it like this, and voila.
Nice. He must have been so excited.
I don't know if excited was the word, but I think he was appreciative.
Okay. So basically you had to instruct the tiler to turn the tile.
Yes, I did.
But we're talking about rotation this morning. What does rotation have to do with turning? I don't get it.
But I'm going to tell you. See here? Right. Well, rotation is actually a transformation that turns a figure about a fixed point called the center of rotation. So basically, it's turning.
All right, so I'm looking at the picture and I'm seeing the arrow here, right, Latoya? And it's showing us this triangle and the fact that it's being turned around or about, as we would say, a fixed point, and this fixed point is right at that plus looking sign, right there. So we have that fixed point. But I want to know, Latoya, because one of the things I like to do when I'm looking at mathematics is see how is it applicable
to real life?
To real life. So you talk about the tiling, but are there any other?
I knew you were going to ask, and I just want to tell you that we're all rotating right now.
But I don't feel like a turning.
That's because of gravity, blessed be. But the Earth is actually rotating around the sun. And so are the other planets in the solar system.
Right.
And then for people like me who cannot afford it, who don't have AC hats them yards.
But hold on, stick a pin before you move on. We talked about a fixed point earlier. So when I look at the solar system, I see the planets and they're rotating, let me use the word, and the sun is fixed.
Right there.
So we have our fixed point right here.
Yes.
And they're making a kind of circular motion.
And if you look at the image closely, they are actually moving on the circumference of a circle. Each planet have their own circle that they're moving on, which is their movement in the solar system. And then when you think about a fan, the blades of the fan also rotate, and then that middle piece will be that fixed point, of course. And as you can see, the bicycle, the Ferris wheel, so you can take me to foreign so I can go on one of those.
Just for the record, my first experience on the Ferris wheel was in Jamaica. Don't be rude.
That's not true. You have Ferris wheel in Jamaica?
Of course.
You have to take me.
Definitely.
All right, and then we have clock, and then for those of us who would have gone to St. Elizabeth or passed through there, when you get to Little Orchard, right there in between Manchester and St. Elizabeth, you see some nice big windmill. I think it's a Wigton Farm. And, we use those windmills to generate energy.
Okay.
Right?
So as I looked at these images, I'm seeing a circular motion coming out, and I'm also able to identify a fixed point.
Yes.
All right. So let's talk about how we go about describing a rotation, Latoya. What are some important things that we need to include in our description of a rotation? So I can think about at least one, because we talked about the fixed points,
Yes.
So definitely I would need to identify that fixed point, which you said in the definition is the center of the rotation. So I'm sure I need to do that. But what else?
So the first thing, as you said, is the center. Then you have to be able to identify the angle of rotation, followed by the direction. So look here now and tell me if you can. Tell me what's happening to this image that you're seeing.
All right, so I'm looking at the image, and definitely I see the center of rotation as it is identified right there. It's actually labeled that black dot there, or shaded circle, small. And I'm also looking for the angle, and it's also identified. In this case, it's 55 degrees.
Yes.
And I see an arrow that is showing me the direction of the rotation. It says clockwise underneath, but I'm not so sure what that is yet. But I'm sure you're going to tell me
I got
as we get into the lesson. But I see the three things coming out in this picture right here.
And it's as simple as that, right? All right, so when we talk about the center of rotation in particular, as we would have said, we're talking about a fixed point about which the object or pre-image is turning. And I just want to zoom in a little on the words object or pre-image. We can use those interchangeably. What we refer to as the object or the pre-image is that initial shape or object
or
that
the original.
Yes, the original. Is that called original? Right. So that original shape or object that you're going to rotate.
Got you.
Also, you can this point may be inside or outside of the shape being rotated. So the center of rotation can be inside of the object or pre-image, as you can see here, and as the tiler would have used a center of rotation inside of the middle of the shape, right?
Yeah, so this almost looks, though it's not square,
right,
as we would have seen with the tiles, but we can see the same idea coming out in this trapezium that is being rotated. We're seeing where the center, that fixed point around which the rotation is taking place, is actually inside this trapezium.
Yes, and by the way, this is, if we were talking about the tile, this is an imaginary fixed point, right?
Right.
And that's an actual point.
So we didn't actually see it literally, but we know, right?
And then, as you can see with the second image below that, we're having the center of rotation being outside of the image, represented at O there on the diagram.
Definitely. Right? So we're saying that it can be either inside or outside. And of course, it could also be a point on the vertex or some other, on the boundary of the object. Just put that in.
Right.
All right.
All right, now we're moving on to the angle of rotation. Tell me what you think this one is.
Well, I think it would be the degree of the turn that we're making. Right. So I'm rotating right now. Not sure of the degree, but I'm doing a rotation, right?
Yes,
so we're talking about the measure then of the turn that is made. So that would be our angle of rotation.
Definitely. And that angle can be from 0 to 360, of course.
360.
360.
Definitely. Degrees.
Yes. All right, so I have a scenario for you. Sue and Roger were asked to make a 90-degree turn. Who is correct?
So, all right, hold on. Wait. So Sue and Roger were asked to make a 90-degree turn. I'm betting on Sue, right? Yeah.
Are you sure that's your final answer?
Yeah, but I'm seeing where Sue made a 90-degree turn. Look at where she was facing initially in the picture up at the top. And then the one below is showing where she's facing. Now, of course, she made a 90-degree turn.
Okay. So what about Roger?
Come to think of it, in a Latoya, Roger actually looks like he made a 90-degree turn as well.
He did.
So are we saying that they both made 90-degree turns?
They did.
So how am I going to... It means that something is missing then, because we need to have something a little more precise in order to follow this instruction. Because if you tell me to make a 90-degree turn, really and truly, you know, I could turn that way, or I could turn this way. So you're going to have to be a little more precise.
All right. Hold that thought, and we're going to circle back. All right.
All right. I like that. We're going to circle back.
You get that?
Yeah.
All right. So when we talk about the direction, which you are asking about, of a rotation, then we can go either clockwise or counter or anti-clockwise. So some people say anti-clockwise, some people say counterclockwise. Both of them mean the same thing.
Okay.
So, when we talk about a clockwise movement, just think about the clock. This is a turn in the same direction as a turn made by the hands of a clock. Literally, clockwise.
Yeah. Makes sense.
Yes. So think about moving from 12 to 1 to 3 to... Yeah. All right, yeah, man. You see what I say. Right? So when we talk about now anti-clockwise or counterclockwise, this is a turn in the opposite direction to the turn made by the hands of the clock.
So hold on, stick a pin, because you know it's maths we're teaching, but I have to drop in like English in there.
Yes, man.
Yes, so when we talk about anti, we're talking about, you know, against or the opposite of. I hope the English teachers don't kill me, but that's what I remember.
So not
from
anti like your mother's sister.
No, girl. Okay. So anti-clockwise would be going against or in the opposite direction to the hands of the clock.
Right.
It makes logical sense.
So this means now that you'll be moving from 12 to 11, 11 to 10.
Okay.
Back way. Just saying.
Okay, if I saw my clock moving like that, I would run and scream, just saying.
All right. I want you to look at this image, though, in the middle, and I want you to tell me what you notice about the degrees, the angles of turning.
All right, so first of all, I want to point out that I'm noticing that the point... So the original, let me just put that there. The original is this red dot right up at the top here.
Right.
So our object or pre-image would be this dot here.
Yes.
And I'm noticing that it's rotated 90 degrees clockwise and ends up right here.
Yes.
And I'm noticing that if it was rotated 270 degrees counter or anti-clockwise, it ended up right here. So it looks like it ended up at the same place.
It did.
So there must be something interesting here then, because I'm seeing here where a 90-degree clockwise rotation and then 270-degree counter or anti-clockwise rotation ended up with the same result.
It did.
Interesting.
So what can you tell me then?
So that would mean, so suppose I did, for argument's sake, a 90-degree counterclockwise. So let's say I did a 90-degree counterclockwise.
Right.
Yes. And I did a 270-degree clockwise. You're saying, based on this picture, that I would get the same result as well.
You should.
I'm also seeing, I've seen a lot of things, forgive me here.
That's okay.
So I'm looking at it and I'm seeing this circular motion that we spoke about earlier, right? I'm seeing it coming out here as well. And if I remember correctly, the complete turn is 360 degrees.
Yes, it
is. And I'm looking back at this and I'm seeing 270 degrees compared to 90 degrees. If I should really find the sum of those two values, I'm actually getting 360 degrees.
Yes, you are.
So let's take it up a notch. So let's not use 90 degrees or 270 degrees. Suppose I did a clockwise rotation of 300 degrees. Remember now, clockwise rotation of 300 degrees. Are you saying that I would get to the same place or I'll be facing the same direction if I'm moving on spot as moving anti-clockwise direction 60 degrees?
You should.
Interesting. Every time I come here, my appreciation for maths just turn up, you know?
You can thank me later. I'll take cash.
Or whatever.
All right.
All right. So this is interesting stuff, though. Interesting stuff.
All right. So then... also, a positive, okay, don't get confused. Stop where you are. Listen to my voice keenly.
All right.
A positive angle indicates an anti-clockwise turn, while a negative angle indicates a clockwise turn. I'm going to say that again. I'm going to say it slowly. A positive angle, like 270 degrees, indicates an anti-clockwise turn, whilst a negative angle, negative 90 degrees, indicates a clockwise turn. It might sound confusing, but that's just, you know, how
the convention.
The convention, right?
Yes.
So just remember, if you see a negative angle being represented, you need to move in a clockwise direction. And if you see a positive angle being represented, it's an anti-clockwise turn. Okay? Don't get confused.
All right, got you.
All right.
So let's take back now, looking back at Sue and Roger, who were asked. So I noticed the precision has come in, and we're seeing the counterclockwise now dropped in. So now we can make a determination who is correct.
Yes, we can.
So let's check it out now.
So it's asking who is moving in a 90-degree clockwise turn.
Counterclockwise.
Counterclockwise, thank you. So let's see. Roger is moving in a clockwise direction, as we would have discussed. And Sue is moving in a counterclockwise.
Girl power rules. So Sue...
You said both. You don't get the point. Sorry.
Whatever. But in this case, Sue is correct.
All right.
So let's go a little bit deeper, Latoya, because there's so much to explore. Now, I want to know, how is it that we actually rotate a shape?
Got you.
I need to know how to rotate a shape. So here we're looking at rotating, or we're being asked to rotate a trapezium A, B, C, D. And the rotation we're to perform is a 90-degree anti-clockwise rotation. And the center for this rotation is the point 1, -1. And of course, we're asked to draw its image. A prime, B prime, C prime, D prime.
So I want us to stop and identify or 3 things that we would have discussed from the question. Are we seeing a center of rotation?
Definitely 1, -1. That
Are
point.
we seeing an angle of rotation?
90 degrees.
Is there a direction of rotation?
Anti-clockwise.
Fabulous. So we can go ahead and start.
All right. So let's see how do we actually perform this rotation. So firstly, we need to identify and mark the center of the rotation, right? And here we have seen our little dot pop in right at 1, -1. Good. Then next we need to draw a line segment connecting a vertex from the trapezium to this center of rotation. All right, so let's see our line segment popping in. Now, remember we talked about the fact that it's a circular turn that we're making?
Yes, ma'am.
And so what we're going to be doing here is to actually draw a circle or an arc, but we're going to go with the circle in our case.
Yes.
And we're using the line segment that we have on screen as the radius of that circle. Good. So we now know that A prime is supposed to lie somewhere on the circumference, Latoya, of this circle that we're seeing on screen.
Yes. Before you continue, though, can I just say, we would have mentioned A prime, but I don't think we would have said to our viewers what A prime is. So when we rotate an object or image,
or pre-image,
sorry, we denote or represent the name of the shape, which is now our image, as primes. So for example, for this, our object or pre-image is ABCD. So when we would have rotated ABCD, now we would get A prime, B prime, C prime, D prime.
So it's pretty much just separating or being able to identify which is our object or pre-image and which is the image.
Yes.
All right, thanks for that, Latoya. So we're noticing here, let's go back to the circle, that A prime is supposed to lie somewhere on this circle.
Yes.
Right? So let's see what we do next. So we're going to have to now measure and mark the desired angle. In our case, we said 90 degrees anti-clockwise. Good.
Yes,
so let's see if we can measure our 90 degrees here. All right, so I can identify 90 degrees. Let's put a dot there, Latoya. There is 90 degrees and it's anti-clockwise.
Yes, ma'am.
Great. So after we have measured and marked the desired angle, notice now I've drawn a line segment. Remember now that we said earlier that A prime must lie on the circumference of this circle, right? And so we can identify exactly where A prime would be, where our line segment now is intersecting the circle. All right, so I'm seeing it coming up a little late, but so we're seeing now A prime coming in. So it's a 90-degree rotation from the center of rotation, and we would have identified our center to be 1, -1.
Yes, and I would also like to point out, when we're using the protractor to measure our angle, we are measuring from the object or pre-image. So that radius connecting the point from the pre-image to the center of rotation. Yes?
Right. And remember now, we would have spoken earlier about this circle and the fact that in this case, we're noticing the center of rotation is actually what we have used as the center of the circle that we're using here to perform our rotation. So one of the things that we want to bring out here, Latoya, as well, is the fact that the distance from the center of this circle, so I needed to bring up A prime, the label. Right, so I'm noticing that the distance from the center of the circle to A is the same distance as from the center of the circle to A prime. That makes sense, not true?
Yes, there are 2 radii.
Definitely, definitely. So that's important for us to know.
Because we know that any point from the center of a circle to any point on the circumference going to give us a radius, yes?
Yes, definitely. All right, so we have here, and I wanted to point out, so earlier we just rotated the point A, but we were asked to rotate the entire trapezium, and so we would have to repeat those steps that we just spoke about for each vertex to see where our image point will now lie. All right? So here on screen, you're actually seeing the circles that were used in this rotation. All right? We're seeing those coming out, and I want you to get the students. The idea of the circle is very important as we consider the rotation. So we were asked to do a 90-degree anti-clockwise rotation about the center 1, -1. So we need to double check, Let's check if all of these, when we connect the pairs of points to the center, are we getting 90-degree measurements here? So let's look at A. All right, so we had A and A prime connecting to the center, and we're seeing 90 degrees there. Let's check the others quickly. And we're seeing, again, another 90 degree there for B and B prime connecting to the center point. All right, C and C prime, and we're seeing that 90 degree. Again, we're measuring from the center to see that line segment. We're measuring from that line segment the turn that's made. So we can clearly see the anti-clockwise turn taking place here.
And I'm also seeing, Karima, that both the points from the pre-image and the image lie on the circumference of the circle, that same circle.
Well, we have several circles, but yes, for each pair lie on the same circle. Very good, very good. So I just want to point out clearly, because I know as we were, contemplating, we figured that, we need to reinforce something here, because students tend to have a little difficulty with the protractor. So I want to remind our students that when we're actually going to be measuring the desired angle, we must ensure, one, that the center of the protractor is aligned properly with the center of the rotation. So that point that we were given as a fixed point.
To center.
There you go. And we also need to ensure that the line segment that we had from the center to A in this case is properly aligned with that 0 mark on my protractor. All right, so I just wanted to clear that up and ensure that our students are raring and ready to go. All right, so we're gonna go back to where we were at the end of the break, and I did mention that we're going to be looking at the properties of the rotation. So Latoya, as we look at this, we're seeing our object, our pre-image, and we're also seeing our image. Are there any similarities?
All right, so they still look congruent to me. When I say congruent, I'm meaning the same size. The angles didn't seem to change. The length of the sides didn't seem to change either. So I'm seeing that the both pre-image and image are same in size proportion in all sense.
Okay, so congruent in one word.
And then, you know, it seemed as if somebody, you know, kicked down the trapezium.
All right, you're sounding a bit violent now.
Or it fell over on the back, you know. So the side AD is now horizontal instead of vertical.
On, stick a pin. I asked about similarities, you know.
Oh, so,
and you will look like
sorry.
Is which English class you went to?
That's cool,
all right, so we talk about congruence, but I want to also point out, look, let's examine the labeling, the order of the labeling.
All right.
So as I'm looking, let's start from point A, right? And I'm going in a counter or anti-clockwise direction.
All right.
So if I'm looking at my labels, I see A, B, C, D.
Yes.
Yes, and that was anti-clockwise. Let's check my image. So of course it's now A prime, but nonetheless. So we have A prime, still going anti-clockwise, B prime, C prime, D prime. So the order of the labels
still the same.
Still the same.
Still the same shape.
That would be a similarity.
Yes.
So I know you're excited about differences, so let's go there. What is it that you were saying now? Please don't say kick down.
All right. Oh, no, this is what I'm going to say. It turned different.
All right, so I get you. So you were saying that the line segment AD, which was vertical when I look at the pre-image, when I look at A prime, D prime, that's now a horizontal line.
Segment.
Thank you. Horizontal line segment. So, so it can turn different then, that way I say.
So no turn the shape, it
well,
true, turn different.
True. So let's delve a little deeper. Let's just sum that up as the properties of rotation. So we noticed that every point on the object or the pre-image makes a circle around the center of rotation. And we did that. We actually walked the students through.
Yes.
Right. And because of that, and you said it too, that A and A prime were on the circumference of the same circle, not true?
Yes.
So based on that, we also saw that the distance from the center of rotation to any point on the object or pre-image. So if we're thinking about the one we just did, say, for example, from the center to A, right? That distance is the same as the distance from the center of rotation to the corresponding point on the image. In this case, A prime, based on the one we did.
And then we would have said that's because there are two
radii. Definitely makes sense. So let's see what else. We noticed also that an object and its pre-image, you said this, the object, or pre-image and its image are congruent. And you did explain that we meant same size, same shape. But it's your time to chime in, you know.
Different.
Right. The figures.
The orientations will be different.
All right. So.
Can be different. Not all the time. If it's a 360 degrees rotation, it's going to come right back where it was. Right?
Yeah, definitely. Because that would be a complete turnout.
Yes.
Yes. All right. So I want us to delve a little deeper. So if we noticed the rotation that we performed earlier, we had a center of rotation as the point 1, -1.
Yes.
But there are some times when the center of rotation is actually the point 0, 0, or what we call the origin.
Yes.
Now, when that happens, some special things happen where the coordinates are concerned.
It's true?
Yeah, man. Now we want to explore that a little more. So let's look at the anti-clockwise rotation of 90 degrees about the origin. And in this case, the origin is labeled D.
All right.
So let's take a quick walk through.
Even though you might see the origin being labeled O, usually.
Yes, usually. But in this case, we have used D. No big deal, but we know that this point is 0, 0, right?
No problem.
So let's examine. Let's look at the coordinate for A, Latoya. Right, so we're seeing that coordinate as 2, 4. Let's look at A prime. -4, 2. I want you to look at the lots. I need you to observe what's happening. Let's check now the pair B and B prime. So B, we have 6, 4. And B prime coordinates, -4, 6. All right, let's check C, see if we see anything. So C, we had 2, 6 as the coordinate, and C prime, -6, 2. So you know I'm going to ask you what you noticed, right, about these coordinates. Tell me what's happening here.
Okay, let me see now. All right. So I realized that, so 2, 4, -4, 2. Okay, so the X and Y values would have interchanged. So the X and Y values for the object would have interchanged for the image, sorry.
All right, so what you're saying basically is 2 was the X value in the object, and you're seeing that 2 being the Y value on the image.
Yes.
Okay, what else did you notice? So we spoke about that. What else did you notice about?
The Y value also interchanged to be the X value. So Y from the pre-image, the Y value from the pre-image is now the X value for the image, but not just.
Okay.
It is the negative of.
Okay, because I was about to like, what? Okay.
So it's the negative of. So the X and Y
we could say opposite
value,
too, not true? Because we talk about opposite numbers on the number line, right? Okay. Interesting stuff. Interesting stuff. So then, we can make a generalization, yeah? Because we notice the same thing happening for these 3 points.
Yes.
So we can therefore conclude that if we have a point with the coordinate xy, whatever those values may be, and it undergoes this anti-clockwise rotation of 90 degrees about the origin.
Only.
Thank you. We're talking about the origin only.
0,
then
0.
We're expecting that the resulting point would be the negative of whatever the y value was. That's now in the x position, so to speak. And the original x value is now where the y value. So it now becomes the y. So Latoya, what if I have, because I don't want to have any misconceptions, you know, because it looked like all of those x values, the new ones, all of them look negative. So what if I had a particular point, 3, -5, and it undergoes this rotation?
Oh, that's easy, man. So so I'm interchanging my x and y values, but I'm finding the opposite or the negative of the y value. So that would be 5, 3.
Let me see if you're bright.
Long time.
All right, you passed the test. You passed the test.
Good school.
So this is interesting things that, you know, students can use to assist, you know, in looking at rotations and, you know,
only
examining
if it is being done at the origin, and for this particular one,
and for this angle as well, in this case, 90-degree anti-clockwise rotation about the origin.
What about rotating at 100 degrees above
180.
180 degrees. Probably need to change
about the origin. And I notice here that we didn't give any direction. You might be saying, so how them say, you know, we must give direction and so on. But when we look at the 180 degree though, whether we move clockwise or anti-clockwise, we're really gonna be facing the same results, basically.
Makes sense, because 180 degrees is half of 360.
There you go.
And whether you go left or right, half point, you're going to meet right in the middle.
All right. All right, so let's look at the coordinates quickly, because we have so much to explore, you know. So we're still looking at A, which had the coordinate 2, 4. And A prime now has -2, -4. Hey.
Interesting.
Interesting indeed. Continue. Let's look at B. We had 6, 4. And now B prime is -6, -4. Let's look at C. 2, 6. And C prime is -2, -6.
It's easy, man. It's easy.
So tell me what you noticed then and stop saying it's easy, right?
Well, I've noticed that it is the negative of the same x and y values.
Oh.
So the values of the image, the coordinate, sorry, for the points for the image is the negative of that of the pre-image. The sign of the angle, and I just want to say that the sign of the angle tells the direction of the rotation.
Right. So we had mentioned that earlier, that the positive angle would have indicated an anti-clockwise rotation.
Yes.
Yes, but since we're doing it in words,
yes.
Yes. But okay. Now, so talk about what we noticed then. So if I have a point X, Y, and it undergoes this particular transformation, this rotation here, 180 degrees about the origin.
It's going to be negative X, negative Y.
So it's going to be the negative of whatever the X was and the negative of whatever the Y value was. Great. So let's take our point again. 3, negative 5.
That's easy, man. I'm just finding the negative of the value. So that's going to be negative 3 and positive 5.
You're too bright.
I know.
Let's move on. Let's look at another one. And you may be saying, why are they looking at these specific ones? You know, these are the common ones. So we're highlighting those that will be most beneficial to you.
And let me just highlight again, we are looking at the ones that are being rotated about the origin.
Definitely.
Only 0, 0.
For this section.
0, 0, it does not apply.
There you
know,
go.
you're only getting things and it's a condition apply. Condition is about the origin. Okay.
All right. Okay. So let's look at the anti-clockwise rotation of 270 degrees about the origin. Yes.
Okay.
What do we expect to happen here?
All right.
So again, let's explore quickly.
We know A is 2, 4.
Right. So let's look. All right. So we're just going to look at what's happening as we see the points come up on screen. So we have 2, 4 mapping to 4, negative 2.
So A prime is now 4, negative 2.
And then as we looked at B and B prime, we had 6, 4 mapping to the point 4, negative 6.
So B prime is now 4, negative 6.
And C and C prime, as we examined those, we have 2, 6 mapping to 6, negative 2. Those were the points that we saw for C. And of course, you need to make the observations.
All right, so I'm seeing that the X and Y values would have interchanged for the image. So the X and Y values from the pre-image would have interchanged for the image. But not just that, I'm also seeing that what was the X value and now the Y value is opposite.
In terms of, we're talking about the sign here.
Yes.
Being, makes sense.
So I'm seeing the negative of the X value to be the Y value of the image.
Oh, makes sense. So we had 2, 4, and we're noticing that this Y value of 4 is actually now my X value.
Yes.
And this 2, which was my X value,
is now my Y value.
Now my Y value, but it's the
negative of it.
Or the opposite of it.
Or the opposite.
All right, great observations. So I think we're on track with what we're doing, yes?
Yes.
But again, we want to ensure that we do a point separate and apart from the ones we have. So let's look at this one, which has the point 3, the coordinate 3, negative 5. What happens if this point undergoes this particular rotation? So let's take it step by step. We know that this negative 5 here, which was the original Y value, is really now going to be in the X position.
Yes.
Correct? So the coordinate will be negative 5.
Yes.
Let's see what will be in the Y place now. So we had a positive 3 right here.
Right.
And we notice that it's the negative of that. That should be here. So I'm expecting negative 5, negative 3. Beautiful.
Jinx. Oh, my orange juice.
All right. So we want to explore a little bit more, but we want to remind students that what we just did and the patterns we just observed are for these specific rotations that take place, specific angles that take place, and direction. Remember, look at it anti-clockwise we spoke about. Rotations about the origin.
0, 0.
Now, Latoya, I want us to look at sometimes, you know, we are not asked to do the rotation or to perform the rotation. It's already done for us.
It's already done.
All right, and so we need to figure out what's the center of the rotation that has already been done for us.
Okay.
So we need to know, how is it that we go about finding the center of rotation? Now, remember, Latoya, I don't know if you remember, but there's this property about circles, right? That if we actually, the perpendicular bisectors of chords in a circle, yes, they pass through the center of the circle.
It's true.
Yeah, man. So guess what? If I want to find the center of a circle, I can just draw a chord, find its perpendicular bisector, draw another chord in the circle, not parallel to that one, of course, and draw a perpendicular bisector for that too.
I hear what you're saying, but I want
anywhere they meet, Latoya, that's the common point. Anywhere they meet is going to be the center of that circle.
All right, I prove it.
So we're going to operate on that principle.
Okay.
We're not going to prove it now, but that's known, right? But that's what we're going to use to help us to figure out how to find the center of rotation.
That's what I mean.
How we really find the center of one circle still, not sure.
Yes,
because
we talk about rotation.
There you go.
So
let's talk about how we go about it. So first, we need to connect using line segments. We need to connect at least two pairs of corresponding vertices. So for our case, we're going to be connecting A to A prime. And we're also connecting B to B prime.
All right.
You're not seeing the circles, but these are chords for the circles. That's what I was saying
Imaginary
earlier.
Circles.
Yes.
And then we would have known that the corresponding vertices would touch the circumference of the same circle.
There you go.
So we know that.
So we can therefore, based on what we just discovered or talked about rather, that we can draw perpendicular bisectors for these line segments, which we know are chords of circles that would have been used. So let's put in our perpendicular bisectors. All right, so we're seeing the first one come in. I remember perpendicular bisectors.
Cut the line in half.
Not just that, but form a 90-degree.
That too.
Yeah. So here we have our two perpendicular bisectors.
Oh, and I see that those perpendicular bisectors intersect.
Exactly. And since we know they must pass through the center, both of them, then wherever they meet must be the center of rotation.
Love it.
In other words, the center of the circle, right? Looked at how to find the center of rotation. And we said we need to use a line segment or line segments to connect at least two pairs of corresponding vertices.
As seen
in the diagram, we also drew the perpendicular bisectors of each line segment. And we're saying that wherever those perpendicular bisectors meet, Latoya, that would now be the center of rotation. So in this case, our center is 0, 1.
And voila.
Voila. But guess what? Having found the center of rotation, we now need to find the angle of rotation.
Not a problem.
Not a problem at all. So first of all, let us use line segments to connect a pair of corresponding vertices to the center of the rotation that we found. So let's connect A to that center. And let's connect A prime to that center. There you go. So now we need to measure the angle that is formed. And remember now we're measuring from the line segment from the center to the object or the pre-image point,
please.
Right? So let's see if we can get our protractor in and actually measure what's happening here.
And remember, the center of your protractor needs to be at the center of rotation. Center match to center, can't forget.
All right. And again, we're seeing here that we have aligned 0 with the line segment from the center to A. So let's measure. In this case, we're doing anti-clockwise. Yes, so let's look at anti-clockwise. And that looks like a 90-degree, Latoya, go back. Yes, 90 degrees.
Right.
So we can say, therefore, that the transformation that maps this object
A, B, A, C
to the image
A prime, B prime, C prime
is an anti-clockwise rotation of 90 degrees about the point 0, 1. Beautiful.
All right.
So I think we need to do a CSEC question, don't you? All right, so let's look at this question. So it says the graph shows triangle DEF and its image D prime, E prime, F prime after a transformation. Then tell us which one.
They say
transformation. Describe fully the transformation that maps DEF to its image, D prime, E prime, F prime.
Okay.
So, Latoya, I think Monday it was.
Yes.
They looked at translation, don't?
Yes.
So tell me if this looks like DEF was, it just slide onto D prime, E prime, F prime.
Well, based on what I can recall about translation, the orientation will be the same.
Oh, yes, so could it be translation?
No.
Is it a reflection?
That was done yesterday?
Yes.
No.
Does it look like a turn, though?
It kind of does.
Yes, it looks like it does turn.
This way.
Yeah, it does turn.
Oh, okay.
But guess what?
Yes.
So we can say that it's a rotation, not true?
Yes.
So if we're going to describe fully, remember it says fully. So we need center.
Yes.
Angle.
Yes.
Direction.
Got you.
Go. So let's talk about the center. So we would have just done that earlier. So let's talk through. So we're connecting E to E prime, and we're drawing its perpendicular bisector.
Yes, ma'am.
Beautiful. Let's do another. D to D prime, and we are drawing its perpendicular bisector.
And there we have our center of rotation.
But Latoya.
Yes, ma'am.
Man. This center is the origin.
It is.
All right. Let's always center down. What's the next thing again?
Angle.
Angle. Let's get the angle in. So we're connecting a point from the object to the center. In this case, we're using D. And we're connecting also D prime to the center. So we didn't bring up our protractor now, but we would measure, of course, from the line segment from the center to D, and we're measuring the angle that's formed from this line segment to this one.
Yes,
all right, so we'll be measuring here. And we're seeing here that it's a 90-degree turn. And that's clockwise or anti-clockwise? We need to say that first.
So we're going from DEF to D prime, E prime, F prime, so that's an anti-clockwise. So
I
have to do my body, you know, and don't feel no way if you have to do your body too.
All right, so this is an anti-clockwise rotation of 90 degrees about the origin. But guess what? We had talked about this earlier.
Yes.
So let's look at the coordinates then. So we had D being 1, 2 as the coordinates. And D prime was -2, 1. Same thing that we said. Yeah, man, we talked about the values interchanging, and we also spoke about this Y value here, which was 2.
The negative.
The negative
of the X, the value.
No, in the X place. So guess what? Students, we have given you another strategy, you know, to double check your answers. Yes, double check your answers. So let's conclude, Latoya. Triangle DEF is mapped onto triangle D prime, E prime, F prime by an anti-clockwise rotation of 90 degrees about the origin.
I think I just made up a dance, you know.
All right, Latoya, we are moving on. So let's summarize. Okay. We have done a lot. So let's just quickly summarize. So we're saying that a rotation is a transformation that turns a figure about a fixed point. All right? When describing a rotation, ensure that you include the center of rotation,
yes, please,
the angle of rotation, and of course, definitely the direction of the rotation.
Yes, ma'am.
All right? So these are very important.
And remember, clockwise.
Direction of the clock and?
Anti-clockwise. Anti-clockwise.
All right, so.
We're out of time. Unfortunately, I wanted to show you another dance move.
Fortunately.
For this lesson. Thank you so much for joining us today. Keep practicing. Don't forget.
And stay safe. Sanitize.
Wash your hands.
Wear your mask.